This is the first lesson of our three-part series talking about significant figures. But first of all, welcome to our channel, The Random of Science. And today we will talk about significant figures. Before we dive deep into our lesson, let's first talk about how significant it is to understand the concept of significant figures. In our field, it is quite important because it deals with the accuracy and precision of numbers, and it gives us an idea of how uncertain our final results are based on our calculations. Now let's go over the rules for significant figures. One is that all non-zero digits are significant. This means that digits from 1 to 9 arranged in any form is significant. Example would be 1, 2, 3. This has 3 significant figures. Another one would be 2, 1, 3, and 6. This has 4 significant figures. Another example, 3, 1, 2, 4. This also has 4 significant figures. Another one, 9, 6, 9, 9. Also has 4 significant figures. Last one, 1, 2. This has 2 significant figures. Okay, let's jump to the second rule for significant figures. The second rule talks about that all non-zero digits that are in between non-zero digits are significant. An example would be 101. As you can see here, 0 is in between 2 non-zero digits. In this example, these are 1. Based on the rule, this has 3 significant figures. Next example would be 10102. This has 5 significant figures. Now looking back at the rule, as you can see here that this 0 and this 0 are in between non-zero digits, such as this one and this one. That's why it is 5 significant figures. Another example would be 1, 2, 0, 1, 0, 1. This has, what do you think, guys? Okay, let's use the rule. So you can see here, these zeros are in between 2 non-zero digits. As you can see here, in between 2 and 1, and in between 1 and 1. Based on the rule, these zeros are significant. Let's count. 1, 2, 3, 4, 5, 6, and this has 6 significant figures. The third rule would be all leading zeros are not significant. To show this, here's an example. 0.0102. The first thing that we should do is look at the first non-zero digit. Here it is 1. Then let's look at the left side, which contains 2 zeros. If this 0 is a non-zero, then the 0 at the left side of 1 will be considered as significant. This 0 is in between 2 non-zero digits. Based on that fact and applying the second rule and the third rule, this contains 3 significant figures. Another example is 0.0000213. Using the rule here and looking at the left side, these are not significant. Looking here, 213, these are significant. This means that this has 3 significant figures. Another example, 0.010. Now let's apply the third rule. Looking to the left, these are 0 and these are not significant. But what's on the right? There's a 0. Does it apply here? Let's discuss on the next rule. The next rule, the fourth, trailing zeros are significant. An example would be using the last example, 0.010. As you can see here, let's identify the left side is not significant. But this 0 on the right side of the non-zero digit is called the trailing 0, and this is significant. Based on that, this has two significant figures. Another example would be 0.00233900. Here, let's look at the left side. This is not significant. But these zeros on the right side is significant. And this has 5 significant figures. Another example would be 0.023010. Looking at the left side, this is not significant. Now looking at the right side, this 0 is significant. And this 0 is in between two non-zero digits, which makes it significant. Now let's count. This has 5 significant figures. And a few more examples. Then what if you have 2.003210? How many significant figures are there? Using the rules that we've learned, as you can see here, looking at the left side, there are 2 zeros and a non-zero digit. There is the number 2, which makes the zeros in between 2 and 3 significant. Now let's look. This 0 is in between the digits 2 and 1. This makes it significant. And there's a trailing 0, which also makes it significant. Now, let's count how many significant figures are there. There are 8 significant figures. Another example. Now, what if it's in scientific notation? Here's an example. 156.1 times 10 raised to negative 3. How many significant figures are there? Using the same rules, the 4 rules here, these are non-zero digits, which makes it 4 significant figures. Here's another example. 1201.00 times 10 raised to 2. How many significant figures are there? Now, applying our rule, as you can see, this 0 is in between the digits 2 and 1, which makes it significant. And on the right side, these are called trailing zeros, which makes it significant. As you can see here, this is 6 significant figures. Here are some sample problems that you could try, and comment your answers down below in our comment section, and let's try and answer this one and discuss the answers on our next video. So thank you for watching our video, and please like and subscribe and comment down below if you have any ideas or lessons that you would want to learn. And once again, thank you.